So welcome to the next installment of the Calbridge seminar series, Science by Diverse Scientists. I am very excited that we have Dr. Rocio Ng here with us. I'll admit Rocio is a good friend of mine, and I'm excited I managed to sneak a non-physicist in our physics seminar series. But Rocio has a background in ecology and evolution. And she is a scientist that went from the world of STEM to the world of tech. So I thought she would be a great example of what you can do and how you can use your science degrees in a context you might not have considered a traditional path for a physics or astronomy degree. Rocio I feel like I should know your bio by now. Why am I flipping it in my head? Rocio is from a New York City native from the Bronx, and she got her undergraduate degree at New York University. Before moving on to Stony Brook University, which is also in New York, to get her PhD in ecology and evolution, where she studied the evolution of fruit flies. And from there, she was selected to the Insight Data Science Fellowship in the Bay Area, which essentially takes fresh PhDs from science and trains them on the skills they will need to thrive in the tech industry. From there, she worked with Kickwheel, which was a startup app designed to kind of work on phones to give students information about college decisions and college choices. And from there, she jumped into LinkedIn, where she is now a senior data scientist. So, Rocio, thank you so much for joining us, and I'm very excited to hear your talk.
All right. Thanks, Sarah, for that introduction. I'm very excited to speak with everyone today and share my experience, especially, as Sarah mentioned, from being primarily trained in biology, but being able to kind of transfer a lot of those skills into industry. Now I've been working that for several years. So I hope to share my story a little bit, talk about like what this data science thing is, and talk a little bit about my work, the stuff that I've been working on currently. So it's gonna maybe be a little bit different from some of the other talks, but we'll hopefully it will be enlightening for everyone. Let's see. Okay, cool. So this to just kind of set the stage here for the agenda for today. So I'm going to talk a little bit about my background, and then I'm going to talk a little bit about how I transitioned into data science and some of the lessons learned there. And then also talk about like what that is, how that applies to industry, and then LinkedIn life and some of my current endeavors, both within and outside of work. And then I want to like leave a good chunk of time for a Q&A. But feel free to ask questions throughout the seminar if anyone needs any clarification on things. All right, so I think a lot of this was covered by Sarah's wonderful introduction. So yeah, I'm a data scientist at LinkedIn. I think most folks are familiar with that company. It's basically a social media network. So it's like Facebook for professionals, I guess, is the best kind of analogy that we have. And in my outside of that, I actually also work as a volunteer. I manage this data science group that works on different civic tech projects, and I'm going to talk a little bit about that. And I also mentor data science fellows. I give back to the Insight community since they help me so much, but I also work more formally with other aspiring data scientists. So any questions about the, specifically with career transitions, I can certainly help with that. And I also am kind of breaking into being a data science advisor for startups. So as you can see, I'm like very involved in this world, but I don't just do data science. I also like to do things outside of that. I play music. I like to go on bike rides and hiking. That's been really nice now during the pandemic. And I do art, as you can probably see in the back there. All right, so just kind of a reminder of my path. So NYU to Stony Brook, then this Insight Data Science, then a very small startup. I'll mention, I think I was employee number 11. So that was an interesting experience to kind of work from there for a couple of years. And then moving on to a really large company like LinkedIn and a much bigger team, going from being the only data scientist to being in a team of over 200 people. So there you go. All right, so I'm just going to talk just briefly about my grad school year so you can understand where I'm coming from. So as Sarah mentioned, I studied Drosophila. And so Drosophila are the fruit flies. You probably see them if you leave out any fruit for too long. They are major model organisms for all kind of genetic studies. So I was looking at the evolutionary genetics of pigmentation traits, actually, since we think they're adaptive to different climates. So I was trying to understand what specific like factors may be contributing to that variation. So I worked on the sequencing, I collected a lot of my own data, I did field work, I did a little bit of everything. And in that process, though, I also did a lot of statistical analysis and modeling. And some point in my career in grad school, I started picking up these skills. So I started learning how to use R to do a lot of statistical analysis and data processing, since I was working with genetic data all the time, and having to build these pipelines from scratch, and also learned a bit of Python as well, and started developing a really strong interest in those social things. And as I started considering options outside of academia, I explored a lot of things in that realm. So not just data science, actually, I looked into software engineering, web development, all those kinds of things, since you're in grad school for so long. And I think I remember feeling like that kind of spark when I started learning this stuff. So I started exploring this more. But then I found out about this field called data science. And this was several years ago. So this is back when I think even now, like more and more people are starting to see the term, that it's a very common thing now that people are familiar with, but back then it was still kind of a emerging field, and not much, at least for me, was known about it. And so I started exploring this as an option, because it seemed like it had a lot of the applications were kind of similar to the kinds of things I was thinking of, was working on as a scientist, like how do you solve complex problems using data, using statistics, but also leveraging technical skills such as programming and things like that. So I became fascinated by this, started exploring that. And so I decided to take a little bit of a leap, move to the Bay Area to participate in the Insight Data Science program. And they continue to exist and train data scientists, and they've expanded to other professions like DevOps and cryptocurrency and things like that, which is pretty cool. But back then they only did data science and data engineering. And basically, I built a fully functional data-driven product while I was there in 3 weeks. It was an art discovery engine, which was pretty fun. And what was really cool about that was that I was able to meet a lot of folks from different data science teams across the Bay Area, from places like Facebook, Netflix, Airbnb, to really, really small startups, and getting a good idea of how data science was being applied across the industry. And then through them, I got introduced to different teams, and they kind of set you up with interviews and things like that. And through them, I got a job offer at the startup that Kickwheel, which is the college finder app that I worked at for a couple of years. And so I would say, so this is just very broad generalization of the things that helped me transition successfully, but there's a lot more there. But I would say I did take a lot of time to go outside of my comfort zone to explore different options. So when opportunities came up in grad school to kind of learn these things, so I took an advanced stats seminar, which then applied a lot of where I was able to apply more of that R knowledge and modeling knowledge that I was starting to pick up. And then while I was finishing up my dissertation, I started taking online courses in data science and Python and those kinds of things. And back then there was only so many. I think now there's a ton of resources out there. And the other thing that I did was I went to tech meetups in New York City and kind of networked a bit just to find out more about this world, because I've been really involved in in academia, and a lot of people associated with were in that industry. So this allowed me to kind of meet people from tech, talk to them, see what they're working on, just kind of, or what kinds of what kinds of products they're building, that sort of thing. And so that allowed me to kind of get a better idea of the world I'm potentially what's going to start to transition into. And then also while I was doing my graduate work, I like I mentioned earlier, I started picking up these skills in R and Python and SQL. And what was also useful about that is that those skills were also directly applicable to the work I was doing, and actually enabled me to do my research a lot more efficiently. So I would mention that R at the time in the department was only being used by a very few number of people at the time. Right now, I think they require everyone to learn R, but at the time it was still pretty new. So like I had to take it upon myself to pick up that knowledge, but then again, it like helped streamline things a lot. And then on the other side, on the non-technical side, I also learned a lot of skills with time and project management. I started utilizing this, there's this like kind of way of doing project management called getting things done and breaking tasks down and things like that. So I took courses in that as well to get better at that. And believe it or not, that's really important to any kind of career or job that you'll hold in the future. All right, so now we're going to talk a bit about like what is data science and who are they, right? So maybe you've like, I think if you Google data science, you tend to see this kind of Venn diagram pop up. And the kind of the point behind it is that folks who are data scientists are kind of a blend of these different areas. So computer science, math and statistics, and domain knowledge. Domain knowledge being like specific to like business or healthcare or, risk, if those are the types of problems you're working on. And that encompasses a data scientist. And as you imagine, the expectations are kind of all over the place, but I think that's what allowed so many people from different backgrounds to kind of get into this industry, since there's not like necessarily like one defined background that you need to have. Right now, there are formal data science programs, but folks are still coming in from different things, not just physics. I mean, biology, like me. I know an ex-architect who broke into it. So yeah, and also just because there is these three components, like data science may be strong in one area versus the other, or maybe expected to know one or the other. And I'm going to go into that a little bit, but folks who work more on like machine learning might have to be stronger in computer science, for example, where like someone like me, a product data scientist, has to be stronger in math and statistics, since we do a lot of experimentation and analysis. All right, so just kind of like, make things a little bit more tangible, we're going to talk about Netflix. I assume most folks here are familiar with Netflix, might have a Netflix account or access to a Netflix account. Either way, you probably have seen it or watched some of their content. So they are one of the biggest companies leveraging data science in probably every aspect of their business. And I'll talk a little bit about those examples. And they're kind of on the developing a lot of the bleeding edge technology there. Right, so as you probably noticed that, if you sign into Netflix, if your friend signs into Netflix, you see different things, right? And there's a specific reason for that, right? They want to provide a personalized experience for everyone. And basically they're optimizing for certain behaviors, right? They want you to find something to watch as quickly as possible, right? That's probably not a big surprise. So they're trying to show you content that you're going to be most likely to be interested in, right? And that it's not even just that, it's like the placement of everything. So you can see here, like even the ordering of like continue watching moves around, where your list is, different genres and things. That's in a way is a recommendation. The ordering of the titles, also the artwork. They've done a lot of work trying to optimize what type of artwork, like based on like your activity and engagement with the product, they kind of determine, which artwork for a particular title that you're more likely to respond to. So that may explain why you might see different artwork for titles at different times. There is intention behind that. And there is a model working behind the scenes to kind of figure that out. And so how are these recommendations generated? It's actually, it's a pretty complex process, but generally a lot of these recommendation engines, and so it's not just in Netflix, you've probably seen it in like Amazon or any other kind of retail things where they make recommendations of things to buy. They generally use like some kind of blend of what's called collaborative filtering or content-based filtering. And there's other kinds of techniques in there, but just to kind of demonstrate like, you know, some of the common things here. So collaborative filtering is basically using activity and engagement of all their users, like what they're watching, what they're engaging with over time to kind of determine, okay, these two users may be similar to each other because they tend to watch a lot of the same shows or movies or genres, etc. And so maybe like, you know, this user here might have seen something that this user here has not seen before. And so that recommendation gets made because the model determines, okay, this user here has a very high likelihood of liking this content, right? And so they're using, so it's, that's why it's called collaborative filtering, because it's like using like, kind of like like preferences over time and users to kind of make those recommendations. And then content-based is just purely based on the features of the content itself. So like, for example, like this person really likes comedy or likes, I don't know, rom-coms particularly, or some kind of like specific subgenres within there, then they're more likely to like another movie within that genre or something that's similar to that movie based on just kind of physical feature, those like features. They could be things like the actors, the directors, the when the movie was made. So feature things about the specific movies themselves. Yeah. All right. So also, all this modeling work behind the scenes is also generating the personalization of the experience, but there's also other aspects of data science that drives like how a product gets made, how new features get introduced. So I think maybe a lot of students here may be too young to remember, but this is what like Netflix used to look like in the past. It's very different. It's not as sleek looking, or maybe as engaging to you. Definitely it's like blocky. You don't have these like big panels, for example. And so what drove that decision to go from here? I mean, first of all, it happened over the period of many, many years as the team introduces new features and new user experiences over time. But that is informed by data science, by folks doing analysis of engagement with the platform, understanding, okay, where are users getting blocked? Maybe they're only scrolling past a certain part. Maybe they take this long to watch a film. Maybe they're not watching movies to completion. And so how can they introduce new features to kind of optimize those behaviors? So those get introduced over time. And so that's what leads to kind of product changes. So as you know, in summary, right? So data science is not just playing a role in the actual like product, the personalization aspect itself. It's also helping the business make decisions about the experience for their users. All right, so just to kind of like break things down a little bit to kind of see it from another angle. So as you probably are starting to imagine, data science roles kind of vary quite widely, and also the types of work that you do is going to vary depending on the type of data science you are. So you could be more on like the descriptive analytics, more on the analyst side, where you're building dashboards to kind of monitor metrics. So metrics, understanding performance of a particular product. So that might be like, you know, what are the daily users, you know, for something like Netflix, like what's the average watch time per person, or something like Facebook, like how many likes are posts getting, for example. And then they have dashboards to monitor those metrics. And then there's folks who work more on the predictive analytics part. So that's where a lot of that modeling, where the recommendation systems come in, understanding behavior and predicting like, oh, when is a user likely to churn? For example, churn means they're not going to use the product anymore. So what can they do to bring them back? Things like that. And then there's things like experimentation where they look at, introducing new features and seeing the impact on these metrics and things like that. And with prescriptive analytics, it's more like doing analysis to identify new opportunities, like maybe certain demographics are not having the same experience or ease with a platform as another one. Maybe older users are having issues with your platform. So how can we improve the experience there to help those users? So that's one example. All right, so yeah, and with that, data science is not just a wide number of roles, but also has a wide number of applications throughout many different industries. I think there's obvious ones like, self-driving cars, the AI that kind of recognizes objects within a field of vision, but then, and also, personalization, like I mentioned, social media sites like Instagram and also optimizing routes for Uber cars. But there also plays a role in things for companies like Walmart, believe it or not. Walmart's not really a tech company, but they have, I don't know how many stores across the country, how many warehouses that supplies products to those stores. So determining the optimal routes for those trucks making deliveries is actually a data science problem, and they have a team that works on that. And then healthcare is also another field where data science is growing, like understanding patient outcomes, predicting disease, and those sorts of things. So it's everywhere. All right, so now I'm gonna kind of change gears a little bit and talk about specifically LinkedIn and the team there. So LinkedIn's a pretty big company. We're not quite as big as Google or Facebook, but we're up there. We have about 14,000. I think that's probably a little outdated at this point. It's probably more like 15 or 16 plus. So this is worldwide. We have offices not just in the US, but in Australia, Europe, South America, and Asia. Right. And we're not just the social media site that you may be familiar with. We actually have a lot of business product lines that we offer to customers, and that generates a bulk of our revenue. So examples being, I'll talk a little bit about the one I work on, which is the recruiter product in a bit. And then we have actually a division between between the data science and AI team. So the data science team at LinkedIn primarily works more on the business product side of things. So like understanding how our users are engaging with the product, driving business decisions with data. And then the AI team works more on the kind of the personalization relevance part. So like if you're doing a search for a job on LinkedIn, they're the ones building the models that kind of determine what jobs to show you. And then my team may understand how is the job seeker's journey being completed throughout LinkedIn? How can we make it better? And I would say the data science team is pretty large at this point, at least 200 people. I think we're growing, we're hiring all the time. This is one of the sub teams I'm part of that called the hiring marketplace team. And back when, before we could actually all see each other, we do these fun offsites and get together, which is really cool. And so we have opportunities to get to know each other on a personal level. All right, so I talked a little bit about what data scientists do. I'll get more into detail. So we kind of three general areas. So one is this thing called metric development. So a metric, I think I talked about it a little bit earlier. So metric is just kind of like ways to measure performance of particular products or features. So something like daily logins, or something on LinkedIn is how people are interacting with the feed, like how many people are engaged members, that's a metric. And engaged, we define people who are, maybe logging in regularly, have a complete profile, those kinds of things. And we help define and make them accessible to our business partners. So like a product manager is able to say, okay, how is this particular product that I'm working on doing? And they can have access to that data. And then we also do a lot of analysis to look for opportunities within the product. So identifying areas where we can improve, like where are we seeing users drop off in, like maybe in completing their profile on LinkedIn, maybe not as many users as we like are uploading their photos. So we might make a recommendation to the team, like, hey, like users, maybe we say college students are less likely to upload their photos. Like, what can we do to improve that experience for them so that they feel confident in doing so, like, things like that. And then there's this thing called A/B testing, where we experiment with any new features. And I'll go into an example in a bit so you can understand what that means. But it's a type of experiment that we do to kind of make sure that any product features that we introduce is having the impact that we are intending to drive. All right, so I'm going to talk through one example here. So there's this feature called People You May Know. And I think this kind of feature exists in other platforms. So like Facebook tries to tell, it's similar. I don't forget what it's called on Facebook, but it's like, friends you may know, or like, if you're any kind of social media site that you get recommendations for users to follow and things like that. So that's this feature. And actually this feature was actually invented at LinkedIn many years ago. And so as you can imagine, this allows people to grow their network. And the more, the bigger your network is in LinkedIn, the more information we get so that we can help them, but also like the better they're able to leverage the platform, because it's also a networking platform, right? And so we look at a lot of different features to kind of predict who a person might know, like, things like school, did they go to the same school? Did you graduate at the same time? Are you in the same industry? Those are the kinds of things that we use as features to make these predictions about colleagues that you may know in real life, or maybe colleagues that you may be interested in being introduced to, right? And so this feature, as I mentioned, has been around for a long time. And so it's gone through different iterations. So as I mentioned earlier, sometimes we introduce changes to a product, and you probably see this all the time in stuff you use. New features get introduced, new colors, new experiences, new flows, things like that. Sometimes you hate them, sometimes you love them, but generally when we do this, we try to make sure generally it's providing better value for our users. So we do what's called A/B testing, right? So here's the old experience of the People You May Know feature. Here's a new experience being introduced. And what you do is you kind of, like a scientific experiment, you break up your users into a control and treatment group. So the control sees the old experience, the treatment group sees the new experience. And then what you do is you run an experiment for particular amount of time. You have outcome metrics that you measure. So here might be like, are the people in the treatment group adding new connections at a higher rate than those in the control? And if you see that that's the case, and we do hypothesis testing, we make sure there's statistical significance, then we can feel confident in moving forward in introducing this feature to all our users, right? So part of this is to also make sure that like introducing a new feature is not gonna like, completely piss everyone off and like, make us lose users and value for them in the product. All right, so now I'm gonna talk a bit about my specific role at LinkedIn. So I work not on the main social media platform, but kind of one that's more behind the scenes, called recruiter. So as you can imagine, like a recruiter, someone who's trying to source and hire for a particular job at their company that's open, right? And so the product allows users to search for candidates that may qualify. So here I just did like a sample search for data scientists in the San Francisco Bay Area, and it returned a bunch of results. So this is utilizing the rich data set that we have of users in the LinkedIn platform, because we have all the experience that people have had in their past, where they went to school, the types of skills that they accumulated, how many years of experience, and all that is fed into our search relevance model that then returns the results to the user. And then you can easily find candidates to then reach out to. So here's like a little, you could send them a message, you can add them to a project, you can share them to other people on your team, say, hey, what do you think of this candidate? So on. And so I spent a lot of my time kind of looking at what's called an engagement funnel. So in recruiters. So our engagement funnel here is defined as like people logging in, right? They can't do anything if they're not logging in. They do a search, like I just demonstrated, and they look at the profiles. So the profiles is like, their view is similar to what you see on LinkedIn. You see all that information for a candidate, all the past experience and so on. And then if they are intrigued by what they see, they send them an email, which is just what we call messaging in LinkedIn. And hopefully they get an email accept, meaning that the other person's interested in applying to whatever role that they're trying to recruit for. And then hopefully they get a hire from that. And so a lot of my work has been kind of understanding this whole process, understanding how do we define users so we're getting more value from the platform, and kind of defining a lot of these metrics here. My most recent project is actually digging through into the search feature itself and trying to understand, is there biases in our search? We know there are, we've seen evidence of that, but understanding where in that process that's happening and kind of doing an audit from both like the AI's perspective. So like, is it the AI that's causing a lot of bias? Is it behavior? Is it a mix of both? So like, biases in AI has become a pretty large topic these days. Maybe you've come across some of that. And that's become something that is a growing issue, especially in things like healthcare, for example, where like if a model is trying to predict, prevalence of a disease, it may only predict well in, certain gender, one gender over the other, or certain groups better than other. And it's not a fault of the AI, it's just a product of the data that it's getting, that it's training on. And that happens all the time. As part of this, we're trying to kind of understand, is the AI that we're using, is there any biases that we can find? What are the sources? How can we solve them? Also, again, is it also how our users are engaging with the platform, maybe certain filters they're using and things like that. So I'm trying to work on those specific things to understand and uncover that and make recommendations to the team, both product and AI teams, and how they can make this better. And I'll mention this is also kind of part of a larger initiative at LinkedIn that's been happening, that's been growing actually in the last year, to kind of promote diversity and diverse hiring within the platform. So for one thing, like we are trying to collect race and gender data from our members, which, as you can imagine, it's very, very sensitive stuff. And this is something we take seriously. We're trying to be sensitive about how we collect this data, how we use that data. And it's actually been helpful for us because take for my project, if I could fully understand like the distribution of different races across different industries and stuff, then I can understand better, where biases might be occurring and how can we solve them. And there's other applications that LinkedIn is working on that I can't really talk about, but I can say that much. One example that has come out recently is we're building this representative search. So one thing we have found in the past, and I can't talk, this is public information, is that as I mentioned, our search AI tends to favor male candidates over female candidates when showing results. For example, if a underlying distribution of gender for like an engineer is, say 50% male, 50% female, the search is not going to necessarily represent that. It will skew heavily more towards males. We don't know why. But we did build another layer in the model that kind of redistributes that so that the distribution of the results that it returns represents what's the underlying distribution. So that's pretty cool. And then one thing I am currently working on is understanding. So we know that, for example, that there is gendered wording and job advertisement. There's been some research done on that and how that can impact like a person's perception when they're applying to jobs. Like there's been research also showing that like female candidates tend to apply at a lower rate than male candidates. And one hypothesis is how the jobs are presented, possibly the wording. So I've been doing some of the work around that, understanding this is happening at LinkedIn Jobs. And we're currently, exploring tools that kind of help our job posters be more inclusive in the language that they use when they post jobs. So it's all really, really exciting stuff. And with that, I also like to just quickly plug there, all the different data science opportunities at LinkedIn. We're hiring all the time for data science and AI roles across product analytics, machine learning, experimentation. So like whatever you're interested in, we have lots of things to cover there. We also have economic graph team, which is a bit more research oriented. It's just now that we have all this rich data set of skills and jobs and movement in different places, we're trying to use that to just kind of understand like different economic trends. So there's a lot of really cool stuff there. We also have a data science internship that we do every year for students. I shared the information with Sarah, so like, ping her if you're interested in that, or, I'm happy to address questions about that. Let's see how we're doing with time. Okay, so I'm gonna just quickly, I just wanted to quickly like talk about some of the work I'm doing outside of LinkedIn, just so I can give like a more, because I could only talk about so much about the work I'm doing on LinkedIn, because a lot of it is proprietary information, but I can talk about this pretty openly. So this is some of the work that I'm doing with Code for San Francisco. So I mentioned I kind of manage this group of volunteers, and we work with a bunch of different government and nonprofit organizations. So you can also see that data science is very useful in the applications there as well. So one of our most successful projects was a partnership with an agency that collects homelessness outcome data within the Bay Area. And so they wanted to understand like what kinds of services, what kinds of things contribute to successful outcomes. So a successful outcome meaning that that individual finds permanent housing. And they want to look at these particular segments. So like veterans, chronically homeless, males versus females, that sort of thing. And I'll give a quick example here. So when you're building some kind of predictive model, you want to like kind of put together a number of different features or input variables that you think might be contributing to the outcome. So the outcome here again is whether they find permanent housing. And so this team looked at a bunch of different features, from demographic things like ethnicity, race, to what their situation is, like how long they've been homeless, and any disabilities they had. And so one of the sample results within women, so they fit different models for the different demographic groups, and they find, so basically what's happening here, so they did a logistic regression. You get this thing called odds ratio, which gives you an understanding of how important that feature is to predicting the outcome. So for example, for women, things like if they were a veteran or they had state adult health insurance, that were high predictors of a successful outcome, versus like if they had a drug disability or domestic violence victim, they were less likely to see a successful outcome. And so this is like more, this is a modeling analysis that's used to be more inferential to kind of to inform these groups, like what can they do to make these programs better. So one example that comes from this is to suggest, well, if a woman comes in as a domestic violence victim, they're not probably being addressed as strongly as like people who aren't and maybe need more attention. So that's like one, possible insight to come from this that then like these agencies can use to improve their services. All right, so with that, I will conclude there, and we could thank you for listening, and yeah, we could move into the AMA portion.
All right, thank you very much. We had some questions come in already. Well,
Awesome.
one is my dean, who asked like a million questions. So we'll start with Michelle, who asks, is there one overall AI that handles your LinkedIn platform, or several of them, and do they overlap? And if there's more than one, and is there a favorite? So about kind of the AI that's powering things.
Oh, okay. So I'm not on the AI team, so I don't fully understand like, the full AI world at LinkedIn. But what I can say is that we don't just have one AI. We have an AI that kind of powers a lot of our kind of prevalent features. So like an AI model that handles the feed, like what content you see when you log in. We have AI. So the people you may know, that's an AI. Jobs you may be interested in, that's another AI. When you use the search within the main product is separate from recruiter search. And and even with, I can speak a bit about the recruiter search because I'm working on that. So I became familiar with how that modeling works. It's also not just one model. It's kind of these modeling layers that takes in different features that I don't know the full details, but it's very complex, and it kind of creates different rankings, and from that the final results come out. So yeah. And what was the is there a favorite AI? I'm not sure. Was that one of the questions?
Yeah. The one that's the least biased against people, probably.
Oh, least bias.
I was going to say your favorite is probably the one that has the fewest biases.
Yeah, I mean, that I don't know, because again, like I'm not sure. So there are people working. So what I'm doing for recruiter search, people are doing for the other things. I think the jobs you may be interested in, they just released some of their results, and there was some interesting there. There is bias there. There's bias everywhere. I don't know if like any of the, not sure if any of them are free of that. But yeah.
Sastry asked a lot of questions and then left me a note that's saying I don't have to ask them all, but I like some of them because I think they're really of interest to students. So what is your workday like? Is it a lot of programming? What else do you do during your day?
Yeah, so I would say this is coming from someone who's like, I'm a product data scientist. So since a lot of the work I do is in partnership with product managers, I'm not just doing analysis all day. I'm also in meetings. I do a lot of planning. I do a lot of what we call stakeholder management, where it's like where we communicate timelines and any blockers to our partners. And then as we get results, we also communicate those. So I spend a bit of time on like kind of my core projects, which is, like this analysis on the search audit that I'm trying to get out. That's part of my day. But then I'm also like in meetings, planning other projects that I'm working on. There's also like team meetings. The other thing too is like, as I move through a project, there is the initial parts of the project are a lot of like data processing. So I'm doing a lot of coding at that stage. And since our data is really big, I have to use things like this technology called Spark, which is parallel processing of a lot of data. So I might be coding a lot in that. And then I might move to SQL and then maybe R to do the kind of the analysis part of it. And then I do spend a good number of time building decks as well, because you can do all this robust stuff, but if you can't communicate and convince your partners of the recommendation, why you're making particular recommendations and why your insights are saying that, this and that, then it's not going to go anywhere. So I also spend a good amount of time in the communication piece. Yeah.
Okay, you managed to answer all of Sastry's questions in like one fell swoop. So a question from Bree, how much of an impact does customer feedback have on improving the products and algorithms, if at all?
Yeah, so customer feedback is actually a big part of it. And it's only something I have come across more recently as I'm doing more of this diversity work, because of the sensitivity of this stuff, there is a lot of customer feedback that we do face. And so we have UX researchers who work on those things. So like for example, like this feature where we ask our members to reveal their, gender and race if they're comfortable, that has a lot of researchers, behind that, actually engaging with members and getting their perceptions on that. And I've seen some of those results there. So that is a big part of it. We also I've also worked on a big product launch for a recruiter. That's one thing I didn't really talk about. It's like we basically launched a new version of it, and we've been migrating customers onto that for the last couple of years. It's been a marathon. And throughout the whole process, we have what are called customer success managers that actually engage with our customers on a day-to-day, and they field feedback from them. We also get tickets from them. So yeah, customer feedback does play a big role. And it's also important for me as a data scientist to make sure I'm not working in isolation of that. I think it's easy to forget that. So it's something I do remind myself that, like, this qualitative feedback exists, and it's actually important to consider. Yeah.
Right. I'm gonna kind of lump two questions together because they're asking similar things. So Fred and Kevin kind of want to know about preparing for this role. And Fred says, as students in physics and astronomy, everyone wants to learn more about data science and machine learning. What they wants to know, what are some recommendations for how students can learn about data science? And actually, Kevin wants to know, you mentioned looking online for topics or like for online data courses, and what topics or elements should you consider when looking for a good data science course to take? So kind of what's a good starting place for students? And then when you're getting more serious, what do you look for?
Yeah, so that is it's become a really broad question, and I'm trying to keep a handle on it. So I think first of all, just before diving into any specific courses or things like that, I think just really understanding what data science means, because I think there's a lot of misconceptions around the field that everyone thinks it's all this sexy AI stuff, which, I mean, yes, some of it is, but a lot of it, is not. I mean, I don't do a lot of my work is not modeling. A lot of my work is actually like crunching data and like writing pipelines and stuff to process that data. So I think just like having a good understanding of what data scientists do, how data science is being applied at different companies. So like, how does data science work at a company like Airbnb versus like a healthcare company? What are the differences there? What are the parallels, right? And like, what is there stuff, is there particular industries or places or, types of data science that excites you? Because that's really going to inform the kind of study or the type of courses that you do. Like if you're more interested in the machine learning, the engineering part, then you want to seek out, those kind of courses that focus more on the modeling aspects of it. Versus if you want to, if you're interested in healthcare, if you're interested in like more analytics, then finding those specific courses make more sense. And in terms of like resources, I mean, kind of like my defaults have been like Coursera and Udacity. Those have been really great places to pick up. I think you can still audit a lot of courses for free, and they still have a lot of good stuff. I know John's, like, I really like the Johns Hopkins specialization in data science. I was in Coursera. That's the courses I took, and they've been iterating over their material for many years. So I feel like it's improved over time. But there are a lot of other things that have popped up here and there. I mean, I would just say like, yeah, I think just having a general idea of like what kind of data science work, what kind of industry you're interested in. And also, is this something you actually want to do? Because I think a lot of folks dive into it because of like the hype around it without really understanding it. I've seen this happen a lot because I talk to a lot of aspiring data scientists.
That is actually like the perfect segue, because we have some more questions about kind of what the job is like. So Kevin writes in two parts. One, PhD research is not fast paced. So what's it like in the business world? Is there pressure to find answers to the questions you are working on quickly? Is it like academic research? And then is there the practical aspects? Is there career mobility, benefits, job security?
Okay. Yeah, those are two things. Okay, so I'll talk about the first thing. So it is very, very, very different from the academic world in terms of speed and expectations. So you probably have heard that cliche, the fail fast thing. That's definitely very true. And also like there's this principle of like 80-20, where like you want to produce 80% of a result with 20% of the effort. Easier said than done, right? So that's actually something that like inside data science actually works on kind of hammering out of you like that idea, that perfectionist idea of like having to produce the most robust, clean, perfect analysis or product. It's like we operate on a mentality of like, okay, find low hanging fruit, come up with some results, some insights, or build like, what's called an MVP, a minimum viable product of whatever product you're building, and then iterate on that rather than trying to build things perfectly end to end. Because businesses move quickly, you need answers fast. So like for example, that language, that analysis that I worked on for job post text, I had 2 weeks. That is a huge question. Is our job post biased, and is it impacting like our users? I had to like kind of figure out a way to kind of start to tackle that answer in 2 weeks. And even I couldn't do like a ton of fancy things. Even like just counting is really difficult when you're working with that kind of data. So like, I had to be a little bit clever and just try to come up with very quick, like ways to kind of like address that question to some degree, right? And it doesn't have to be perfect, doesn't have to be like 100% robust. And that happens a lot with data science. And this is why, setting the expectations, like a lot of the modeling work you do is not like fancy, I don't know, like, the stuff you see that shows up in Kaggle competitions, for example, like that stuff is not scalable. It's not realistic. It doesn't apply in business settings. A lot of times a regression or even simple heuristics work. So it's a lot. Yeah, that's mostly it. And then what was the second part?
About like how the more practical applications.
Yeah.
Is there career mobility, like benefits, job security? What is the work, is it the adult stuff?
Yeah, the adult stuff. So, I mean, I guess compare it to academia or just like generally, actually, just generally, I think data science is a pretty, there's a lot of opportunities right now in data science. I think it's a pretty good viable career option if it's something you're actually interested in and like have the passion for, because it's not the easiest thing to break into. But there, like I mentioned, even companies like Walmart hire data scientists, Macy's, like places you wouldn't imagine. And I think it's only growing. It's a growing trend. So I think in terms of that, in terms of mobility, they're depending on who you are, the type of industry is, I think, folks tend to move pretty quickly within the field. Like I have friends who are managers now, for example. And so there is that progression. It really varies company to company. I know that's one of the sticking point for LinkedIn. People feel like career progression is a little slow, but I think it's something I'm trying to work on. But in any case, it does happen. And then let's see, in terms of, benefits, like stability, yeah, for sure. Like, I think just generally tech, because it's such a growing thing, there's a lot of, funding that gets put into tech there. It's a pretty, there's a lot of good benefits and stability and good pay and those kinds of things in this industry, for sure. Yeah.
And then there's two more questions. I think they're both kind of important, so I want to get to them. Bree asks, is there anything you don't like about your job?
Oh, yeah, of course. I think you're going to find that at any place you work at. So, because it is a big company, sometimes things don't, like, I'm not able to progress as quickly as I would like versus when I worked at the startup. Because when I worked at the startup, for example, I wrote all our pipelines, I defined all our metrics and all that stuff, where, LinkedIn, because it's been around for so long, it's such a big team, a lot of people working on different parts. You might, like, for example, like, we have like tracking data that gets introduced to different products by different teams with different schema. And like, so that kind of complicates the process of trying to be able to find the data you want and how to use it properly. So there's a lot of frustrations there. Some of our tooling, isn't always the best or allows us to be the most productive because we are working on these large data sets. Like if the servers go down or if my VPN connection like doesn't work, then, I have little issues there. I think like there's that. And then, yeah, there is sometimes, you know, days where like I'm spending a lot of time in meetings or planning and things like that. And I just want to do my analysis. So like achieving that balance can be frustrating from time to time. Yeah.
And then one more from Michelle. What's one experience that made you doubt your choice in career, and how did you overcome it? As a female person of color, I know I'm going to run into adversity, and I would love to hear some ways to pick myself up after disappointment.
Yeah, sure. I mean, I guess I could talk more on like the job search side of things. I definitely had moments where I've been very discouraged, especially when trying to find my first role, which is the hardest role to land, especially when you don't have working experience. And yeah, being a woman of color, there has been moments of doubt, especially like, um, you know, I'm part of this like big insight cohort, and we're all like applying for the same jobs, and then certain people getting, you know, the job, and you know that I didn't. Some people getting offers and me not getting an offer, and then like, you know, is it because I'm not less qualified, or is it because, you know, who I am, or yeah, that stuff does come up, for sure. And you know, with those kinds of things, and I'm a career mentor, and when folks face those kinds of things or face rejection, it's like, well, you know, it's inevitable. You're going to deal with rejection. And you know, I also like, one thing I think that reassures me, and I try to use this to reassure others, is like, people don't know how to hire data scientists. It's not a solved problem. There's a lot of very arbitrary decisions and processes that get made. I don't know, like, you know, why are you going to ask a data scientist how to, like, you know, code a, you know, linked tree or whatever, like from scratch? Or like, I don't know, I get these questions like, say I had like a deck of cards, what's the probability of pulling two jack? You know, like, I don't, you know, those kinds of things baffles me. Or like, you know, instances where I'll have, you know, chat with a recruiter, feel like it, or a hiring manager feel like it really went well, and it doesn't. You know, it could be one particular checkbox that you didn't fill, even though you're otherwise a really good candidate. And so it's kind of like a crapshoot in that kind of way. And it's a bit of a numbers game. And so, you know, with that, like trying to just encourage that person, to, you know, keep at it. And also like, if this is, you know, if they're a company that asks these weird kinds of questions to hire their data scientists, that's a reflection of like their team and their culture. So I, you know, try to use that to kind of like help. And also that, like, because there's so many opportunities and roles, it's just a matter of finding, you know, it's a matter of time, I think, you know, and finding that right fit. And I will mention, just like as in, you know, from an insider's perspective, there are a lot of companies that are interested in diverse hiring. They don't know how to do it, and they're looking to us to help them solve that problem. That's one of the reasons why this, you know, diversity initiative is so huge. It's not because, I mean, part of it is like we're trying to do the right thing as a company, but we're also doing it because that's what our customers also want, for what that's worth. Yeah.
Awesome. Thank you so much for coming and chatting with us. That officially concludes the formal Q&As. But if there's any students who want to stick around, Rocio said she has time to answer questions or to have a chat. The way we usually do that, we found it's easiest if you just stick around as an attendee, and anyone who doesn't leave, we'll just put you as a panelist so you can come chat with us. But if you're not sticking around, thank you so much for coming today, and we hope to see you at the next seminar in 2 weeks. All right, I'm going to stop recording, that way if whoever's coming can. Do you want to stop recording?